In chemistry, it's going to be critical that you're able to use certain prefixes with the metric system and convert from one set of metric units to another set of metric units. So while by no means are these all the metric prefixes, I wanted to show you guys the most common metric prefixes. I need you to memorize the name of the prefix, the abbreviation for that prefix, and the power of 10. So for example, the first one I've given you on your sheet is nano. Nano's abbreviation is just N, and its value is 10 to the negative ninth. The next one I believe on your sheet is, let's see, micro, I think? Yeah, micro. Micro is kind of a funny one. It abbreviation-wise, it looks like a U, but it's a mu symbol. It's a Greek mu symbol. So the difference, obviously, is this kind of longer tail here at the beginning of the U. It has a power of 10 equal 10 to the negative sixth. The next one on your sheet is milli, and I know you guys have heard this one before. The abbreviation is just a lowercase m, and that's 10 to the negative third. The next one is centi, and that has an abbreviation of just a lowercase c, that's 10 to the negative second. Deci is a lowercase d, that's 10 to the negative first. Kilo is a lowercase k, and it's 10 to the third, or 1,000, but I do want you to remember the power of 10 over the actual number. And the last one on your sheet then that we use in chemistry often is mega. It has a capital M for its abbreviation, and it's 10 to the sixth. The next thing I wanted to cover in this video is the 3 steps you're going to need in order to come up with an equivalent statement. And I want you to do this anytime you see a prefix, a unit with a prefix in it. And there's 3 basic steps. Step 1 is to write the unit with the prefix twice. And you want to put an equal sign between the 2 units. For example, if I saw the unit millimeter, I would write millimeter, and I would write that twice. Oops, I just ran out of space there. Let's see, I'm going to make this a little bit neater. Let's see, okay. So millimeter, we're going to write that twice with an equal sign in between. That's step 1. Step 2 is to put a 1 in front of the first unit. And the very last step, step 3, is to erase the prefix, in this case milli, and substitute in whatever power of 10 for that. In this case, milli means 10 to the negative third. So now you can see we have an equivalent statement here that says 1 millimeter is equal to 10 to the negative third meters. And again, you need to be doing this anytime you see a unit that has one of these prefixes, nano, micro, milli, centi, deci, kilo, or mega in it. And where we're going to use this thing called an equivalent statement is in dimensional analysis. Dimensional analysis is just a fancy term from changing one set of units to another set of units. Typically in dimensional analysis, you're going to see a line like this with a bunch of lines going vertically, and the thing in the front here, we call this the given. That's the information that's given to you in the problem. And each one of these boxes we call a conversion factor. And in a conversion factor, the line that's in the middle here is kind of like an equal sign. In other words, whatever is on top is equal to whatever is on bottom. And that's the way it is for every conversion factor. When we're doing dimensional analysis, the units that are diagonal from each other always must be the same. So whatever the unit that's in the given, that has to be the unit that's down there. Whenever we're calculating, once we've actually set up our dimensional analysis table, we always put a multiplication sign in front of every number other than the given, and we always put a divided by sign for every number that's on the bottom. The number we're always going to ignore is 1. And I want to go through the first example with you. The first example on your sheet looks kind of like this. It has a 6 and a 5, a 3, a 2, a 1. Then under the 5 there's a 2, under the 3 there is a 5, and under the 3 there is a 2. Or sorry, under the 2 there is a 3. And I want to show you guys the way you'd put this into your calculator. So the way you're going to put this into your calculator, 6, and then you're going to hit the times sign, 5, and then the times sign, the 3, another times sign, a 2. We're not going to do anything with the 1. We're always ignoring the 1s, whether they're on the top or on the bottom. And that's because anything times 1 is the same number, anything divided by 1 is the same thing. And then we're going to put a divided by sign, and then a 2, and then a divided by sign, and a 5, and another divided by sign, and then finally a 3. And then we would hit the equal sign. And that's the way you'd put that whole thing into your calculator. So again, you're putting multiplication signs in front of every number except for the given in your calculator, and then a divided by sign in front of every number that's on the bottom. So I'm going to show you a screenshot of what this would look like on a TI calculator. Alright, there's the screenshot of what this would look like in your TI calculator. The thing that's really weird for students and they have a hard time with is oftentimes this idea of putting multiple divided by signs into a line of arithmetic. But you'll be seeing doing this will be a lot easier in chemistry. If you do this way, you'll have less keystrokes in your calculator. And then if you hit equal, your final answer, like it says here, should be 6. You might want to go ahead and pause the video and try this yourself and make sure you're getting the right answer. Let's take a look at the next problem that's on there. The next problem says, how many millimeters are in 6.12 meters? So I see this unit millimeters. So right away, I want to go ahead and make an equivalent statement, which means I need to write the unit twice with an equal sign in between. I want to put a 1 in front of the first one. I want to erase the prefix for the second one and put in the power of 10, which is 10 to the negative third. So 1 millimeter equals 10 to the negative third meters. And now I want to set up my dimensional analysis. So 6.12 meters is what's given. And here's my dimensional analysis. And like I told you before, the unit that's there has to end up on the bottom. So the unit that's going to be on the bottom of the first conversion factor is meter. And we're changing meters into millimeters. And now let's go ahead and fill in the numbers. In our equivalent statement up here, the number in front of meter is 10 to the negative third. So I want to put that 10 to the negative third on the bottom in front of meter. The number in front of millimeter is 1, so I want to put a 1 there. And that's the way I would solve this problem. Units that are diagonally the same can be crossed out, which is going to leave millimeters as our answer, which is exactly what the question was asking us. So in my calculator, I'm going to type in 6.12. I'm going to ignore the 1. The next number I need to put in my calculator is on bottom. Sorry about that interruption. So 6.12, and then again we're skipping the 1. Then we're going to hit the divided by button, and then we're going to put in that 10 to the negative third. The way we want to put that in is 1, and then hit the EE button, and then negative 3. and then we could hit equal, and that would be our final answer. And because we crossed out the meters, since they're diagonal from each other, we know that our final unit is going to be the only unit left, which is millimeters. And let me show you what this should look like on your calculator then. Okay, so there's what it should look like in our calculator. 6.12 divided by 1e negative 3. And again, we got the e on here by typing in the EE button on our calculator. So it's a button that should look like two capital E's next to each other. So our final answer for this problem is 6,120 millimeters. Now I want to go to the next example. In the next example, it says convert 4.5 centimeters into millimeters. Now here's a case where we actually have two units with prefixes. So let's make two equivalent statements. I'll start out with the centimeters. Centimeters, centimeters with an equal sign in between. Put a 1 in front of the first one. Erase the second prefix. And put in the power of 10 for that prefix. Centi is negative 2. And the next thing I see is millimeters. So millimeters equals millimeters. And again, put a 1 in front of the first one. Erase the prefix for the second one. Put in the corresponding power of 10. So there are my two equivalent statements I'm going to need to use. Now I want to start out with the given, and what was given in the problem is 4.5 centimeters. So I automatically know centimeters is going to need to go on bottom of the first conversion factor. And I'm looking at my equivalent statements. I can see that I can change centimeters into meters. So I'm going to put meters on the top of the first conversion factor. And then I'm going to go ahead and fill in the numbers. The number in front of centimeter is 1. The number in front of meters is 10 to the negative second. And the information for this conversion factor is coming from that equivalent statement. Okay, let's continue on our dimensional analysis. So the fact that I have a meter here tells me that I need a meter down below. And now the only thing I can change meters into is millimeters. And I'm getting this information from that conversion factor, or from that equivalent statement. So the number in front of millimeter is 10 or is 1. The number in front of meter is 10 to the negative third. And now if we cross out all the units that are diagonally the same, you can see the only unit that we have left is millimeters, which is exactly what we wanted to do. And now let's try to put this into our calculators. So in the calculator, we're going to put 4.5 times 1e negative 2 divided by 1e negative 3. And again, what I want you to notice, we are skipping these 1s on the tops and on the bottoms. Your final answer should be 45, and the only unit that's left over is millimeters. So there's our final answer, 45 millimeters for that second example.